A warm greeting to everyone. I am D.M.KALAI SELVI, Assistant Professor, CSE Department, RMDEC College. Now we are going to see training a model for supervised learning under machine learning subject. To train a model, many methods are available, and now I'm going to explain the traditional method. First method is hold out method. Initially, we have an entire data set. You can say that is as 100% of your data set. And we will be converting 80 to 90% as a training data set, that is we mentioned in yellow color. Remaining 10 to 20% of the data set will be the testing data set, and that is given in green color. So the training data set is given to the machine learning algorithm. Here is the procedure in the hold out method. First, the input data will be given, the training data. So the input data actually split into two things. One is training data and the other one is testing data. So training data will be the 70 to 80% and testing data will be 20 to 30%. And the training data will be given to the machine learning algorithm. Now we are seeing for supervised learning method. So under that, you can use any machine learning algorithm. Example, classification. Okay, so after that, the results will be mapped with the test data and both will be checked to get the performance of that model. This is hold out method. And the upgradation can be done for this hold out method by adding another term called validation data set. So what we'll be doing is we'll be splitting the input data into three portions: training data set, testing data set, and validation data set. So the validation data will be present in between the training and testing data. So it is used to measure the model performance. It is also used to refine the model in iteration, in each iterations, and we get the final report of the model. So what are the problems if you're dividing without a validation data set is we won't get the appropriate performance value. So using this validation method, that means we are taking a random sample for a validation data set and we'll be checking whether that will be corrected. I mean that performance level is achieved by that random sample. Now we are going to see K-fold cross-validation, which will come under repeated holdout method to ensure the randomness of the composed data. So in repeated holdout method, several random holdouts are taken to measure the model performance. So as multiple holdouts are drawn, the training and testing data will contain the representative data of all the classes and resemble the original input. So K-fold cross-validation technique means the K means the parameter K will be the number of iterations going on. It can be 10 or 20, is basically based on the algorithm we are using it. So the K, based upon the K value, you have 10-fold cross-validation. That means you are dividing into 10 iterations. So what will be the 1-fold is used for test data and remaining 9 folds will be for training data. So this is repeated for 10 times and 1 for each of the 10 folds being used as the test data and the remaining will be the training data. This is the working algorithm for K-fold cross-validations. The input data, which will be divided into K folds. So if your K value is 10, then it will be a 10-fold. So if it's not mentioned, it will be a K fold. So K minus 1 fold will be the training data and last K fold will be the tested data that will be given to the learning algorithm to the test data will be sent separately and will be matching whether the performance achieved correctly or not. Thank you.